In Activity 2A, we're asked to classify graphs based upon their intercepts, the x and the y-intercept, and also based upon their slopes, whether they be positive or negative. So to do this, we need to look at some graphs. Now, just as a heads up, this is the card sort activity that we did in class, so things will look a little bit different here, but it's the same basic idea. All right, so looking at our graphs, there they are. So first thing we're going to do is look at the intercepts, and I'm going to do the x and the y-intercept together at once because it just makes things go a little bit easier when we're looking at these graphs. So on graph A, I'm looking for the x-intercept, which is where the graph is going to cross the x-axis, and the y-intercept, which is where the graph crosses the y-axis. So looking at this graph right here, this is my equation of my line, and it looks to be like right here is our x-intercept. So it's somewhere between 0 and 1. I don't know exactly where it is, but I know it's somewhere in the middle there. So I'm going to classify that as a positive x-intercept. And the y-intercept is going to be down here at -2. So when I fill out my chart, I'm going to make sure that A is a positive x-intercept and a negative y-intercept. Looking at graph B, similar idea. We're going to look at the x-intercept, which is right here. That's a negative value, so that's a negative. And down here in the y-intercept, we also have a negative. So B is going to be negative for both the x and the y. And for C, this graph is a graph of a horizontal line. So here's my line right here. I'm looking for where it crosses the x-axis, and it doesn't. So my x-intercept, in this case, because it doesn't cross, there is none. It's not a matter of being 0, but none. It doesn't exist. And then from there, I look at the y-intercept, and that crosses at a +2. On to D, we have a positive y-intercept at 3, and we have a positive x-intercept somewhere between 4 and 5. Graph E and graph F are a similar type of idea. We're going to still follow the same pattern that we have. We're going to look for the x-intercept. The x-intercept is right here at 2. And the y-intercept is at +4. On F, we have a graph right here, positive x-intercept, and a negative for the y-intercept. Graph G and graph H, and actually I guess I and J together as well. When we look at the x-intercept for graph G, we are at +4, and our y-intercept is at -1. On H, our x-intercept is at -4, so that would classify negative x-intercept, and our y-intercept is at -3. Graph I is a vertical line, so looking at the y-intercept, there isn't one because it's parallel to the y-axis, and the x-intercept is where the line crosses the x-axis, which is here at -2, so that's a negative value. And then looking at J, we have a negative x, -2 for x, and then our graph is going to be down here, so I'm going to move this down a little bit. And looking at J, we have a y-intercept of -5, so it's a negative x and a negative y for our intercepts. And K is one of those cool ones where we take a look at the graph, and I'm trying to struggle here with, is it positive or negative for the x and the y-intercept? In reality, it's kind of neither. This guy right here is 0, and it's for both the x and the y. And the same thing happens on graph L. The intercept for the x and the y is 0. And then round 3, we were asking to classify by slope, and we'll talk about round 4 and 5 as well, because it's kind of the same idea. We're going to look for positive slopes, negative slopes, and other slopes, and then tell if it's an extreme, which means it's very steep, or kind of a small slope. So looking at A, now if we move left to right, this graph is rising, so that's going to have a positive slope And to me, that looks like a fairly steep graph. Our slope looks like it's maybe, I don't know, maybe 4 or something like that. So I'm going to call this one an extreme, because it's very steep. If I look at B, as I move left to right, this graph is definitely falling. So I'm going to call that a negative slope. And that's steep as well, so that's an extreme as well. Alright, let's look at C, D, E, and F, since they're all on the screen up there at one time. So graph C, I actually can't classify that as positive or negative because my slope is going to be 0. So I'm going to say that this is a 0 slope. And I can't say whether that's an extreme or small because it's actually, the slope is 0. So it's not a matter of being a very steep graph or a very shallow graph. It's not going up at all. Looking at D, going from left to right, we're falling, so that's going to be a negative slope. And for this one, it's kind of in between, but I'm going to say that that's a fairly small slope. It seems like it's not going down at a huge rate, so I'm going to call it a small negative slope. Graph E, again, falling from left to right, so that's a negative slope. And it appears to me that it's a fairly steep graph, so if we're looking at 4, it only takes us 2 x values to drop down to 0. So I'm going to call that an extreme slope. And F looks like a rising slope. I'm going to call that a positive slope since the graph is rising from left to right. And it looks like it's doing it fairly quickly, so that's an extreme graph. The graph of G is also a positive slope. Again, the rate at which it's going up, though it's not very quick, it's going up 1 for every 4 that it goes over. So that's a very small slope. Graph H is a negative slope. It's falling left to right, so this is a negative slope. And I'm going to call that small. Again, we're looking for the steepness of the graph when we're calling it extreme or small, and this is not a very steep graph. It's not moving up very quickly. Graph I is one of those special cases where it's not a positive slope or a negative slope. In fact, it's a vertical line, so we're going to call that an undefined slope. Technically, it's like super extreme, but we don't know if it's an extreme positive or an extreme negative, so we're just going to call it undefined and call it a day on that one. Looking at part J is a negative slope and super steep, so that's an extreme negative slope. And then K and L are the last two, and K will be increasing, so that's a positive slope. It's moving up as we move left to right. And it does look like it's fairly steep. So I'm going to call that one extreme. And L is a negative slope. It's falling. Not sloping, but slope. There we go. Falling as we move left to right. And L, in this case, looks like a small negative. And sometimes we're kind of in the gray area. Is it, a small slope or an extreme slope? But generally speaking, if it's very steep, then we're going to call that an extreme slope.